Hello dear students and a very good morning to you. Well, you might be finding some topics pretty difficult in mathematics so that you are not able to sail through those topics smoothly. Well, I might tell you that nothing is actually difficult. The only thing it demands is time. Pick up any task in your life, be it your personal life, be it studies or literally any task. You give that ample amount of time, it's yours, it's sorted, it's easy. That's what happens with mathematics as well. You give those difficult topics ample amount of time and they are yours, you are able to master them very nicely. And that is why it is very important to devote and invest your time, your focus and dedication to a certain thing and then only expect that thing to give you the correct outcome. That is why over here we have been discussing about the certain questions which are most frequent. It will be asked in your papers in the board exams. You have to invest your time in practicing them, understanding them, and then only you can expect a good result in your paper. So let's do section C of the question paper that we have been discussing. We've completed section A, section B. This happens to be the section C, which will constitute your questions from 13 to 23. Let's look out for them, let's see what all they demand and put in our entire focus and attention to these questions so that we are able to master these topics and they come out to be no more difficult but very, very easy. So let's start with the first question, which is question number 13. Now, question number 13 over here, as you can see, is focusing on the topic direction cosines. So, obviously, over here we are dealing with the concept of direction cosines, direction ratios. So, you have to understand and be clear with these concepts in order to be able to attempt this question. Let's see what the question says. Find the direction cosines of the line which is perpendicular to the lines with direction cosines proportional to 1 minus 2 minus 2 and 0 to 1. So there is a certain line whose direction cosines we need to find. So let this L be the required line whose direction cosines are L, M and N. Now these are three unknown values related to the line L which we are supposed to find in the question. But the things which are going to help us find the exact values of L, M, N is basically the condition that this line L is perpendicular to two different lines. So this line L is perpendicular to say a line 1 and it is perpendicular to a line 2. Now line 1's direction cosines are proportional to 1 minus 2 minus 2. And line 2's direction cosines are proportional to 0, 2 and 1. These are the things which you have to use in order to get the values of L, M and N. How are we going to proceed now? Well, a very beautiful condition which is portrayed before you is the perpendicularity. You know what is the condition of perpendicular lines? Well, in this particular case, there will be three vectors coming into picture corresponding to the three set of direction cosines given to you with respect to the three lines given in the picture. The first vector will be with respect to this pair of direction cosines, Li cap plus mj cap plus n k cap. The next will be 1i cap minus 2j cap minus 2 k cap. And the third will be with respect to this, which will be 0i cap plus 2j cap plus k cap. These are the three vectors which is going to come into picture. And the moment I am talking about perpendicularity, you know that the dot product of two vectors will be 0, between which the perpendicular condition is being imposed. So, this line is perpendicular to this line by which I am just keeping in regard the direction cosine sitting over here. So, this vector is corresponding to this line L, this vector is corresponding to line L1, they both are perpendicular, so their dot product will be 0. So, I have Li cap plus Mj cap plus Nk cap, its dot product with I cap minus 2j cap minus 2k cap is 0. You know what is the definition of dot product? So, L into 1 plus m into minus 2 plus n into minus 2, this is 0. Also, because L is perpendicular to L2, this vector is with respect to the line L, this is with respect to line L2. So, again dot product of this and this will also be 0. That means what? L into 0 plus m into 2 plus n into 1. That means what is it that we have? We have from 1 and 2 basically L minus 2m minus 2n is 0 and 0L plus 2m plus n is 0. The moment you have this, the first thing which triggers inside your mind is the cross multiplication method. So, let us apply that very easily, we will be able to get some values. So, how do we proceed? Okay, so the format of cross multiplication method, well, block the first column, you have minus 2 into 1 minus 2 into 2. Fine? M upon, so block the second column, minus 2 into 0 minus 1 into 1. Then block the third column, 1 into 2 minus 2 into 0. Okay? That means you have L upon 2 is equal to m upon minus 1 is equal to n upon 2. Do not forget L, M, N are direction cosines of our line L. And over here you can see that they are proportional to 2 minus 1 and 2. This is what? Well, the direction ratio concept and nothing else. So, I get from here that the direction ratios of line L are proportional to two minus 1 and 2. So, we basically had the aim of finding the direction cosines, but somehow we have found the direction ratios of line L. And once we know the direction ratios of a line, cannot we find the direction cosines of that line? Of course, that's something very simple. If you know the direction ratios, then the direction cosines of line L will be what? L will be the first direction ratio, okay, 2 whole upon under root 2 square plus minus 1 square plus 2 square. Which gives you 2 upon 9 or root 9, which is 2 upon 3. If I talk about m, m will be minus 1 upon under root 2 square plus minus 1 square plus 2 square, which is minus 1 upon root 9, which is minus 1 upon 3. Next is n. N is again 2 upon under root 2 square plus minus 1 square plus 2 square, which delivers you with a 2 by 3. And so you have with you the values of L, M and N, which are your respective direction cosines of the line L. That's how you deal with this question. This question solely is demanding the concept of direction ratios and direction cosines. You have that concept clear with you, then you will be able to very easily attempt this question. Once we are done with this, let's see what happens to be the next question in the league. The next question is over here demanding what? Okay, so this is in regard with the matrices section. 14th question is giving you a matrix A and the identity matrix of order 2 cross 2. Then find K, so it's asking you to find K, this unknown K, such that when you plug in this K on the right hand side, you get the answer which is produced by the right hand side to be equal to the matrix A square. So whatever A square is the same matrix which is obtained by plugging in a certain value of K on the matrix obtained on the right hand side. So if I plug in that value of K over here and I obtain the matrix 8A plus that many times, whichever is K, that many times identity, I obtain the matrix equal to A square. So let's get started. This is something very, very easy. So the 14th question, it's giving you a matrix A which is 1, 0, minus 1 and 7. If I need to find that K such that 8A plus Ki equals A square, first of all I should know what is A square. If I don't know what is A square, how am I going to see what 8A plus Ki should actually become? So let's find out A square. A square is nothing but A into A, which is what? 1, 0, minus 1, 7, multiplied by 1, 0, minus 1 and 7. Now you know how to multiply matrices. This happens to be the pre-multiplication factor and this happens to be the post-multiplication factor. Over here, the number of columns of the pre-matrix matches with the number of rows of the post-matrix. It's 2. And so multiplication is valid and it results in a 2 cross 2 matrix. So in a 2 cross 2 matrix, you have 1 1th entry, 1 2th entry, 2 1th entry and 2 2th entry. 1 1th entry of the resultant matrix will be what? You are going to pick up the first row and the first column. So first row of the pre-multiplication matrix and the first column of the post-multiplication matrix, and you are going to take the sum of the product of the corresponding entries. So for 1 1th entry, I am going to pick up my first row and first column over here. 1 into 1 plus 0 into minus 1, which gives you 1. Then I want 1 2th entry. So first row from the pre and second column from the post. So 1 into 0 plus 0 into 7. Now I want the 2 1th entry. So second row from the pre, first column from the post. So you have minus 1 into 1 plus 7 into minus 1, which gives you minus 8. After that I want the last entry, 2 2th entry. So from here you pick up the second row and from here you pick up the second column. So you get minus 1 into 0 plus 7 into 7. And this is what is your A square matrix. Once A square is clear to you, I want a case such that 8 times A plus K times identity is this A square matrix, which is 1, 0, minus 8 and 49. Now what is 8 times a matrix A? 8 times a matrix A is nothing but over here the concept of multiplication of a scalar by a matrix is being used, is exactly. So how do you multiply a scalar with a matrix? The idea is very simple. Basically, you pick up that scalar and you multiply it with every element of the matrix. That's it. And you obtain a new matrix which is 8 times the original matrix. Very easy concept. So 8 times a matrix A, where A is 1, 0, minus 1 and 7, plus K times 1, 0, 0, 1 is equal to 1, 0, minus 8 and 49. So as I said, multiply this 8 with every component of the matrix. You get 8, 0, minus 8, 56. Over here, K is some scalar again. So K times this identity matrix again does the same thing. This K gets multiplied with every element of this matrix. What is it that you obtain? A new matrix which is K, 0, 0, K. And this is equal to 1, 0, minus 8 and 49. After that, just use the concept of adding two matrices. Well, they are of the same order. First of all, they can be added. They are conformable for addition. And so, 1/1th component gets added to the 1/1th component. What you get is 8 plus K. Then 1/2th gets added to 1/2th. You get 0 plus 0, that is 0. 2/1th gets added to 2/1th. You get minus 8. And 2/2th gets added to 2/2th. You get 56 plus K. This is the matrix which is equal to 1, 0, minus 8 and 49. Now the concept of equality of two matrices is being used. So what happens? When two matrices of the same order are equal, that means their corresponding entries are equal. So 1/1th entry of this matrix is equal to 1/1th entry of this matrix, thereby giving you 8 plus K is 1, which implies what? K is equal to minus 7. And that was what was the question. The question was to find K. And we have found out K, and this K is such that 8A plus Ki is equal to this matrix which is A square. So this K, when it is plugged in over here, this expression gives you a matrix which is equal to the matrix which is the resultant of multiplying A with itself, which is A square. That is how this question actually uses each and every operation between matrices. We have used what is the meaning of multiplication of two matrices. We have used addition of two matrices, scalar or multiplying a scalar with a matrix, equality of two matrices, what not. So if your concepts on the operations between matrices, or in fact I should say the algebra of matrices, this section is very strong, then you better attempt this question. There was nothing in this question, sincerely. But if suppose for some reason you're not very sure about it, then fortunately you have another question which is lying as an alternate question over here. You can attempt this. Let's see what the question says. Now this is regarding probability. The question says a pair of dice is thrown 7 times. If getting a total of 7 is considered a success, what is the probability of no success and 6 successes? There is a pair of dice which you have, and it is thrown once, then twice, then thrice, and so on till a 7th time. Obviously, because you are throwing 2 dices basically, that is why each of the dice is giving you some outcome. So when you are throwing a pair of dice, you are getting outcomes on both the dices. And then when you are adding, and if you are getting a total of 7, that is a success situation. I have to tell that if I am throwing a pair of dice 7 times, how many times, or what are the chances that I am getting a total of 7 as the final outcome when I add the outcomes of the 2 dices that I am getting? That is what I need to find. So my experiment is happening 7 times. So my n over here, if I say n is the number of times the experiment is taking place, the trial is taking place, is 7. And let x also can be written as equal to small r. Let x be the number of times a total of 7 is obtained, that is, number of successes in 7 throws of a pair of dice. That means if I am interested in 0 successes, that means my x or small r is equal to 0. If I am interested in 6 successes, that means my small r is equal to 6. Now, if you recall, this question is giving a hint of a certain type of concept which is very famous in probability, and that is binomial distribution. Why and how did I actually go to this topic, binomial distribution, at this particular point? Well, you know, our successes in n trials can be done in NCR ways, and these NCR ways are mutually exclusive. The probability of each of these ways happening is p to the power r, q to the power n minus r, where p and q we know what they stand for. And therefore, by the law of addition in probability that we have done, we know that the probability of our successes in n trials can be equal to what? It's actually equal to NCR p to the power r, q to the power n minus r. Yes, that's the concept which is being used, which is probability of our successes in n trials is equal to NCR p to the power r, q to the power n minus r. I know what is my n, I will know what is my r, how many successes do I want is given to me. I want once 0 success and then I want 6 successes. So once I am going to incorporate 0 in place of r, then I am going to incorporate 6 in place of r, my n is equal to 7. So over here the only thing which is left unknown is small p and small q. What is small p? Small p is probability of getting a total of 7 in a single throw of a pair of dice. Over here I am interested in how many times am I getting a total of 7 when a pair of dice is thrown 7 times. For that, what you need is, what is the probability of getting a total of 7 when a pair of dice is thrown just once, and that is going to be standing for small p. So what is this? Well, when you are throwing just once a pair of dice, what are the sample space, or what is the sample space? Basically, you get ordered pairs of the form x comma y, where x and y both are ranging from 1 to 6, because each dice is going to give you outcome either 1 or 2 or 3 or 4 or 5 or 6. So you have 36 outcomes, 36 respective outcomes waiting to be produced when you throw a pair of dice just once. Out of those 36 outcomes, which are the outcomes which actually are going to give me success situations? That means which are going to give me a total of 7. So, a total of 7 can occur in one of these ways. Which are the ways? Either you get 1 in the first dice and 6 in the second die, or you get 6 in the first, 1 in the second, or you get 5 in the first, 2 in the second, 2 in the first, 5 in the second, 3 in the first, 4 in the second, 4 in the first and 3 in the second. So out of the 36 outcomes, these are the 6 outcomes which are going to land you in success situations. And that is why small p happens to be number of favorable outcomes, which are these 6 upon total number of outcomes, which is 1 by 6. On the same hand, q, which is equal to the probability of failure, which is probability of not getting a total of 7 when you throw a dice a single time, a pair of dice when you throw a single time. What is the probability of failure? That is given by 1 minus p, which is 1 minus 1 by 6, which is 5 by 6. Now you have your p, you have your q. You already had your n, you know what is your r. Your r, if your experiment is happening 7 times, either you can obtain success none of the times, or you can obtain success all 7 times. So I know my r for different values of r. I can plug in over here and get the probability of r successes in n trials. First thing the question wants me to tell it is 0 successes in 7 trials. So, probability of 0 success in 7 trials is given by 7c0 p to the power 0 q to the power 7 minus 0, isn't it? So, 7c0 is 1. 1 by 6 to the power 0 is again 1. You have 5 by 6 to the power 7. This is the probability of attaining 0 successes in 7 trials. That means this is the probability which tells you that in your 7 throws of a pair of dice, you are going to attain a total of 7 none of the times. The next probability is 6 successes in 7 trials. So 6 successes in 7 trials happen in how much? What is the probability? 7c6, 1 by 6 to the power 6 into 5 by 6 to the power 7 minus 6. So you have 7c6, which is what? 7 factorial upon 6 factorial into 7 minus 6 factorial. I can write 7 factorial as what? 7 into 6 factorial multiplied by 1 by 6 to the power 6 into 5 by 6 to the power 1. From here, 6 factorial gets cancelled. You get 7. 7 into 5 is 35 and you have 1 by 6 to the power 7. And therefore, these are basically your probabilities of 0 successes in 7 trials and 6 successes in 7 trials. Because this x over here was playing the role of a binomial variate, that is why I have used the binomial distribution technique to tackle this question, and therefore I have successfully been able to obtain the solution. Because binomial distribution directly gives me the formula of r successes in n trials. The moment I have the formula of r successes in n trials, that is what is being asked in the question. So I can use my binomial distribution technique to get the answer, and that's what I did. The only thing was to find out small p and small q, which if you find out correctly, this question is actually a cakewalk for you. So, if your operations on matrices section is very clear, then you can attempt the first question, or else you can attempt this again very easy binomial distribution application question from probability. Let's look at the next question. Okay, so again a choice is given to you. 15th question is asking you to find the intervals in which this particular function is increasing. For that, you should first understand what is the concept of increasing functions, then only you will be able to attempt this question. The first thing you need is to obtain your fx. So fx is given to you. So you should know which function you are testing for increasing or decreasing. The next thing that you have to understand is to find f dash x. So let's find f dash x corresponding to the fx given to you. It will be what? 6x square plus 18x plus 12. Isn't it? That is what is the differentiation. From here you can take out a 6 common. You have x square plus 3x plus 2. So this is your f dash x. The third step says solve the inequation f dash x greater than 0. So consider f dash x greater than 0. We have to solve this inequation. So f dash x greater than 0 means what? 6 into x square plus 3x plus 2 is greater than 0. Now this is what will break the middle term. X square plus 2x plus x plus 2 is greater than 0. Simplify this. What is it that you get? X plus 2 plus 1 x plus 2. Isn't it? You have x plus 2, x plus 1. This is greater than 0. Now, if you want this to be greater than 0, obviously 6 is already greater than 0. Now, 6 into something is greater than 0 only when this thing is also greater than 0. Because product of two numbers can be greater than 0 only if both are greater than 0 or both are less than 0. But 6 is greater than 0. So, this product will be greater than 0 only and only when x plus 2 into x plus 1, this will be greater than 0. The fourth step says once you have solved this inequation, the values of x you have to obtain which come as a solution of the solving of this inequation. So let us find the values of x which when plugged in over here give you that f dash x is greater than 0. Now over here you know at x equals minus 2 and at x equals minus 1 you get a 0 as the output. So let's plot that. This is minus 1, this is minus 2. Because x equals minus 1 and x equals minus 2 give you 0 as the output which you don't want, that means minus 1 and minus 2 are not acceptable values of x which are going to give me f dash x greater than 0. So they are not solutions of this inequation. Now, if this is not a solution, this is not a solution, let us check the areas which come before minus 2, between minus 2, minus 1 and beyond minus 1. So, if I pick up any point from here, suppose I pick up minus 3, plug in minus 3 over here, you're going to get a negative output. Plug in minus 3 over here, you're going to get a negative output. Product is going to give you a positive output. Plug in any value from minus 2 to minus 1, suppose minus 1.5 you plug in over here. From here you're going to get a positive output. Minus 1.5 in place of x is going to give you a negative output. Positive into negative will bring it negative. Now if I talk about this region, beyond minus 1 pick up any value of number, you have 0, suppose pick up 0. 0 you plug in over here, you get a positive output. 0 you plug in over here, you again get a positive output. Positive into positive is going to give you positive. That means for x's belonging to this portion and this portion, I have this product coming to be greater than 0. That means for those x's, I have f dash x greater than 0. So they happen to be my solutions. F dash x is greater than 0 for all x belonging to this portion, which is given by what representation? Starts from minus infinity, goes up till minus 2 excluding minus 2. Union starts from minus 1 excluding minus 1 and goes till infinity. This is what is the portion where f dash x is greater than 0 if I have checked my entire real line. The fourth step, as we were discussing in the algorithm of increasing functions, is that the values of x which you have obtained in step 3 as the solutions of the inequation f dash x greater than 0 are the values of x for which the function f is increasing. Yes, that means here you have attained your solution. You just have to write one line. F is increasing on this portion. Okay, and that is what is your answer. You had to tell which is that portion of the real line over which my function is increasing. So we followed the algorithm of increasing functions and we have this as my answer. Now that this question is done, which just required a revision of the algorithm which follows for increasing functions, let's see the alternate question given in the picture is demanding what? Well, it is saying find the equation of the tangent to the ellipse x square by a square plus y square by b square equal to 1 at a certain point x1 comma y1. Now, ellipse is already given to you. The point is given to you at which I am interested in the equation of the tangent to the ellipse. The thing is, for this particular question, you need a concept of what is in general the equation of a tangent to a curve at a certain point. What is it? Well, equation of tangent to the curve, any arbitrary curve y equals fx, at a point, say x1, y1 given by the point P is what? What is the equation of a tangent in general to a curve at a point P? It is given by y minus y1 is equal to dy by dx at the point P into x minus x1. This is what happens to be the concept of equation of tangent to a curve at a point. That's what we have to find. Equation of tangent to the curve, which is the ellipse, at a point x1 comma y1. But over here, this is not explicitly given in the form of y equals fx. It is given in the form, implicit form. Y is hiding somewhere in the expression. So we are going to follow implicit differentiation to obtain dy by dx, that is differentiating y with respect to x. And so, if I have x square by a square plus y square by b square equals 1, then on differentiating, what is it that you obtain? With respect to x, okay, 2x upon a square plus 1 by b square into 2y dy by dx, chain rule, equal to 0. After this step, what is it that we obtain? 2x upon a square is equal to minus 2y upon b square into dy by dx. This happens to be 2x into b square upon a square into 2y with a minus sign, and that is what is exactly your dy by dx. In a more simplified manner, this 2 gets cancelled. You have dy by dx is equal to minus xb square upon y a square. this is your general dy by dx for any y, any x. So what is your dy by dx at P point, say that is x1 comma y1? It will be minus x1 b square upon y1 a square. Now that you have this complete portion with you, you have x1, you have y1, just incorporate it in the formula and you have your equation of tangent. So let's do that. Y minus y1 equals dy by dx, which is minus x1 into b square upon y1 into a square into x minus x1. To simplify it, take y1 above, you have y into y1 minus y1 square upon b square is equal to minus x1 plus x1 square upon a square. And now simplify, you have y1 upon b square plus x1 upon a square equals x1 square upon a square plus y1 square upon b square. But over here on the right hand side, if you focus carefully, x1 comma y1 is a point on the ellipse, so it will be satisfying the equation of the ellipse, which is x square by a square plus y square by b square equals 1. That means if x1 comma y1 is a point on the ellipse, x1 square upon a square plus y1 square upon b square will be equal to 1, and this implies x1 upon a square plus y1 upon b square equal to 1 is my equation of tangent to the ellipse at a point x1 comma y1. If any point is particularly given to you, suppose 1 comma 3, 2 comma 5, whichever is actually lying on the ellipse, anything that can be, and if at that point the tangents equation is asked, you can just plug in the value of x1 and y1 in this formula and you have your equation of tangent with you. So this is a general formula for any x1 comma y1 point. Specifically, if you are given the point, plug in the values over here and you have your answer. So you have to understand how we obtained this. We just use this concept of equation of tangent and then the entire solution just sailed through. That is how this question was supposed to be done. So over here, either you can do this question which demands the concept of increasing functions, or you can do this particular question which demands the concept of equations of tangent. Any one of them is going to deliver you with perfect number of marks. So note this down, understand this, and then we are going to proceed further. So students, now after understanding this, let's take a look at the 16th question. Begin solving it and then we are going to proceed with the solution. Now this question is asking you to integrate a certain expression. And inside this expression, which is the integrand, I can see a particular pattern of integrand. The integrand is of the type x into something. So this x into something type of integrand reminds me of a certain technique known as removal of x technique. What is this removal of x technique? Well, this technique, if you remember, this question will be a cakewalk for you, trust me. This was what? It said that if you have an integral of the form x into fx from 0 to a, such that two things get satisfied. One is that integral fx dx from 0 to a is known, and second thing is that f of a minus x comes out to be equal to f of x. Suppose these two conditions are satisfied for this integral, which is of the form integration from 0 to a x into some function. Then directly the value of this integral is a by 2 integral from 0 to a fx dx. Yes. And this thing you will be knowing from here. So you just need to plug in that value, multiply it by a by 2 and you have your answer. That is how easy this question is. Just an application of removal of x technique. Over here, let's see what our integrand is. We have I is equal to integration from 0 to pi. So your a is pi, x into 2 sine x upon 1 plus cos square x dx. That is what your function is. So this, if I say, is my fx, I have the very pattern of this I, which is 0 to a x into fx. Two things I need to know. Firstly, let's verify this, and secondly, we are going to verify this. So firstly, this is what I have to verify. So the first thing that I need to show is f of pi minus x is equal to f of x. What is f of pi minus x? It will be 2 sine pi minus x whole upon 1 plus cos of pi minus x the whole square. Now, sine of 180 minus theta is same as sine of pi minus theta. And sine ratio of supplementary angles is the same. So, sine of pi minus x is sine x. But cos of pi minus x is minus cos x. So, over here I am going to get minus cos x whole square, which gives me cos x whole square, or cos square x, which is again my fx. So, I have with me that f of a minus x, f of pi minus x is equal to f of x. So, this condition is satisfied. Next, the point is that I should know 0 to pi fx dx integral. So, 2 I will just take out. I have sine x upon 1 plus cos square x dx. Let's see if we are able to compute this particular integral or not. So, let's use this technique of putting cos x equals t. So, you get what? Minus sine x equals dt by dx, and therefore dx into sine x is equal to minus dt. I have dx into sine x, that will be replaced by minus dt. And if these are the limits for x, so when x is 0 implies t is cos 0, which is 1, and x is pi implies t is cos pi, which is minus 1. Isn't it? This is what we have. Now, therefore, our integral becomes what? Let me say this is I1. So, I1 becomes twice integral. For 0 it was 1, so from 1 to minus 1. Then sin x dx is your minus dt whole upon 1 plus t square. This is what you have. Just take this minus sign outside. After this, this is what? 1 upon 1 plus t square is tan inverse t from 1 to minus 1. So, you have minus 2 into tan inverse of minus 1, which is minus pi by 4, minus tan inverse 1, which is pi by 4. So, what is it that you have over here? Minus 2 into minus pi by 4, which is minus 2 pi by 4. So, this gives you what? 2 gets cancelled, this gets cancelled, this 2, you get a pi. Isn't it? You just get a positive pi. And so that means you have your value of I1 with you, and so this is yes, it's known. So all the hypothesis conditions are being satisfied by the integral given in the question, and so my integral turns out to be this, which is pi by 2, and the answer of this integral, which was I1 as we considered. And therefore Ri is a by 2 into pi, which is the answer of I1, and that gives me this as the answer. That's how easy it is. You just need to decode that the question is about removal of x technique. The moment you have decoded this, your question is done. It's actually done. Because in order to find the integral of fx dx, just f, I have not used something very special or something very great. I just substituted cos x equals t, because I know when I am going to differentiate it, I am going to get sin x as the outcome, which is going to cancel my numerator and give me a simplified expression. That is why I did that. So that's how easy, how direct this question was. Let's see what happens to be our next question. Question number 17. Okay, so question number 17 is differential equation, and the question is to solve this differential equation. Well, if I can see this differential equation, I have something popping in my mind known as the linear differential equation. Well, this is the exact form, the general form of linear differential equation in the first order. Why? Because any differential equation with dependent variable and its derivative only in the first degree present is known as a linear differential equation. And the general form of a linear differential equation in the first order is given by what? The general form of linear differential equation in first order is given by dy by dx plus py equals q, where p and q are functions of x, or they can be constants as well, no problem. If you see any differential equation like this, that is a linear differential equation, and over here we have that kind of a differential equation, dy by dx plus, take this to be p of x, so py equals q of x, where p and q are functions of x. Then directly we know solution, its solution is given by what? What is the solution? Well, y into integrating factor is equal to integration of q into integrating factor into dx plus c. That is how the solution of such a differential equation is given by, where this integrating factor is what? Integrating factor is e to the power integration of p dx. So calculate the integrating factor with the help of p function and plug in the values over here, sort this out, and you get your solution of this differential equation. Over here we have the exact differential equation over here, which is the linear differential equation, exactly similar to this. And so we know how the solution is computed. Let's first find the integrating factor. So we have dy by dx plus py, so my p was sec x, equals q, my q is tan x, right? So this is my p of x and this is my q of x. Then my integrating factor is e to the power integration of p dx, that means sec x dx. And integration of sec x is what? Log of sec x plus tan x. This means e to the power logarithmic of sec x plus tan x gives you just sec x plus tan x. So you have your integrating factor with you. Then the solution just demands to plug in the value of integrating factor. So it is y into sec x plus tan x is equal to integration of q, so your q is tan x, into the integrating factor which is sec x plus tan x dx plus c. So keep the left hand side as it is, no need to alter it. Right hand side becomes what? Tan x into sec x plus tan square x dx plus c. Now I can definitely replace tan square x by sec square x minus 1. Why? Because 1 plus tan square x is sec square x. So sec square x minus 1 is tan square x. So over here I am going to get integration of sec x into tan x plus sec square x minus 1 dx plus c, and thus y into sec x plus tan x is equal to integration of tan x into sec x, which is sec x, plus integration of sec square x, which is tan x, minus integration of 1, which is x plus c. And this happens to be your solution. So I actually did nothing in this question. The only thing which was required was to decode that the differential equation given to you is a linear differential equation of the form dy by dx plus py equals q. Just recall, we just recalled how is the solution of this differential equation given by, and what all the solution demanded. We found all that. We found the integrating factor, then we plugged the value of integrating factor in the solution. We solved the very, simplified the very solution, and we got the exact solution. That's how easy things became. So now, that's how you have to decode what your differential equation is and then proceed how it should be solved. Let's see what happens to be the 18th question. Over here I am given the position vectors of 2 points, 1, minus 1 and minus 2, m. Find the value of m for which these two vectors are collinear. And so, it's obvious that the concept of collinearity of two vectors is being used over here. When do you say that two vectors, say a vector A and another vector B, are collinear? Or you can also say that they are parallel. So two vectors A and B are collinear or parallel if and only if one can be written in terms of the other. That is what? Now that means there exists lambda such that A vector is equal to lambda times B vector, or B vector is equal to lambda times A vector. That is what is the concept of collinear vectors. The moment you find a lambda such that one vector can be written as lambda times the other vector, that means these two vectors are dependent upon each other. The moment dependence come into picture, these two vectors become collinear or parallel. So if I am given that these two vectors are parallel, that means definitely, or these two vectors are collinear, that means definitely a lambda is existing. such that A vector can be written as lambda times B vector, or B vector can be written as lambda times A vector, because that is the only condition for collinearity. So over here, what is your A vector? If A vector is position vector of 1, -1, your A vector is I cap minus j cap, isn't it? And if your B vector is position vector of -2, m, that means your B vector is -2 I cap plus m j cap, right? This is your A vector and this is your B vector, such that they both are collinear for a certain m. I don't know what m is, but for a certain m, both of them are collinear. That means there exists lambda such that A vector is lambda times B vector. So what is A vector? It is I cap minus j cap equals lambda times -2 I cap plus m j cap. Okay? So you have I cap minus j cap equals -2 lambda I cap plus m lambda j cap. When are two vectors equal? Here they are two vectors, they are given to be equal. Two vectors are equal only and only when their respective components are same. So over here I have the component with respect to I cap is 1. Over here the component with respect to I cap is -2 lambda. So I have 1 is equal to -2 lambda, or lambda is equal to -1/2. The next component with respect to j cap here is m lambda, here it is -1, so -1 is equal to m lambda. This means m is equal to -1 upon lambda, but lambda is -1/2, so -1 upon -1 into 2, which gives you 2, and therefore m is 2. That means if this m is incorporated over here, which means if this is 2, that means if your B vector is -2 I cap plus 2 j cap, then these two vectors are collinear or parallel vectors, because lambda equal to -12 is existing, such that A vector can be written as -12 times B vector with this m replaced by 2. That is what is being delivered by this question. Only the concept of collinear vectors was required to tackle this question and nothing else. After that, at just one step, we used the concept of equal vectors. When are two vectors equal? Obviously, when their respective components are same, it's then that these two vectors are equal to each other. Let's now tackle the next question. Pretty fairly easy question this was. Let's see what is the next question. Okay, the 19th question is somehow talking about composition of two functions. It's saying f is a function with domain 0, infinity. Codomain is the collection of all reals. G is having domain to be collection of all reals and codomain to be again collection of all reals, such that f is given to you by a certain definition root x. G is given to you by a certain definition minus x squared minus 1. You have to find FOG. So when I am saying FOG, what is the concept that is required? The function FOG has G written as the first and F written as the second function. We know that. FOG is defined. When is it defined? FOG is defined only and only when the range of G is contained in the domain of F. Until and unless this condition holds, FOG cannot be defined. Forget about finding FOG. If it's not even defined, how can we find what does it look like? So let's first check if FOG is defined or not, and if it is defined, we are going to find how FOG looks like. If it is not defined, end of discussion, there is no FOG existing in this case. So we need to verify this condition. Now domain of f is given to me, it is 0, infinity, close 0, open infinity. I don't know what is my range of g. What is my range of g? So g is from R to R. Such that g of x is equal to minus x square minus 1. A polynomial continuous function over the collection of all reals. So we know that x square is always non-negative, right? X is coming from all the reals. So the square of any real number is always either 0 or strictly greater than 0. It's always non-negative. So this means minus x square is less than equal to 0. Obviously, if x square is greater than equal to 0, minus x square is less than equal to 0. So minus x square minus 1 is what? It's less than equal, or I should say greater than equal to minus 1, right? If minus x square is less than equal to 0, then minus x square minus 1 is greater than equal to minus 1, isn't it? So what is it that you get from here? If minus x square is less than equal to 0, then minus x square minus 1 is greater than equal to minus 1, which means minus x square minus 1 belongs to minus 1 comma infinity, isn't it? So over here, well, this doesn't happen. If x square is greater than equal to 0, minus x square is less than equal to 0. So minus x square minus 1 will be less than equal to minus 1. That's the common mistake students do. Minus x square minus 1, just subtracting minus 1 from both the sides. So this is less than equal to minus 1. This means this particular portion is what? This is nothing but your g of x. G of x for every x coming from the collection of all reals is the range of g. So this is nothing but the range of g, and that is equal to minus infinity minus 1. This is what your range is. Now when you know the range, which is minus infinity minus 1, you know the domain, what do you think? Is this the relation between the range of g and domain of f? Range of g is minus infinity to minus 1. That means all the real numbers less than equal to minus 1. And over here you have all the real numbers greater than equal to 0. These are disjoint sets. They don't have anything in common. So how can this set be a part of this set? Definitely it's not contained in this. And the moment this condition is violated, that means FOG is not defined. FOG for this f and this g is not defined. In fact, if you wish to move to the analytical approach, let's see what happens to be the domain of FOG. Domain of FOG will be all those x belonging to the domain of G such that G of x belongs to the domain of F. Right? That is what is the meaning of domain of FOG. Those points of domain of G such that their images under G are part of domain of F. All those x's become the domain of FOG. So this is what? All those x belonging to the domain of G is collection of all reals, such that g of x, which is minus x square minus 1, belongs to the domain of f, which is 0, infinity. This means all those x coming from the collection of all reals such that minus x square minus 1 is greater than equal to 0. Now obviously x square is always non-negative, so minus x square is always negative, and minus 1 is again negative. So minus x square minus 1 will always be less than equal to 0. It will never be greater than equal to 0. Is there any real number such that when you plug it in over here you get greater than equal to 0? Of course not. Or further I can say collect all those real numbers such that the negative of their square is greater than equal to 1. That is what you need to do over here. Is there any real number whose negative of the square is greater than equal to 1? Well, it is strictly less than 0 or less than equal to 0 also, but it is never greater than equal to 1. Therefore, there is no such x satisfying this, and so this set is an empty set. There is no member in the domain of FOG. That means FOG is just not defined. It's not at all in picture. So, FOG does not exist. If it is not even existing, how can you find what does it look like? Over here, the question was giving you an F, giving you a G and asking you to find FOG. Don't straight away start finding how FOG looks like. You're going to get stuck. The first concept is watch out whether FOG is defined or not. Like here we observed, for FOG to be defined, range of G should be contained in domain of F. Because we observed that the range of G was not at all contained in the domain of F, in fact, not even a slight portion of range of G was contained in the domain of F. That is what we observed through here. That means nothing from the range of G was contained in the domain of F, and that is why FOG is not at all defined in this case. It does not even exist for this F and this G with the respective domains and codomains. And that is why the answer is that there is no FOG. Forget about finding FOG. That is, this cautious question is what is trying to tell you. You have to be very cautious when you're dealing with composition of functions. Let's see what happens to be the next question. Okay, so the next question is giving you a system of equations. So these three system of equations are given to you simultaneously with three unknowns x, y and z. The question is, determine the value of lambda or values of lambda for which the following system of equations fail to have a unique solution. I want that value of lambda which when I plug in the first equation, my system of equation do not give a unique solution. I don't want a unique solution. When do you obtain a unique solution? Well, if you recall the Cramer's rule, that gave you two conditions. What were the two conditions? Well, the first condition was that if you are given three simultaneous linear equations in three unknowns, you have to observe the first thing, whether the determinant of the coefficient matrix given by D is 0 or not equal to 0. If the determinant is not equal to 0, that means it has a unique solution. Okay? And if the determinant is 0 of the coefficient matrix, that means either it has no solution or it has infinitely many solutions. So over here, I am not interested in a unique solution. That means I do not want the determinant of my coefficient matrix to turn out to be non-zero. Three system of simultaneous equations given in three unknowns are going to have not a unique solution when their determinant is 0. Because if the determinant is 0, they are either going to have no solution or infinitely many solutions, but definitely they are not going to have unique solution. So if over here I want my solution to be not unique, the determinant of the coefficient matrix will be 0. That is, the determinant of the coefficient matrix, okay, let's make it lambda 1 minus lambda. Then the second column is the coefficient of y's basically, so 3, 2 and 1. And the last is coefficients of z, so minus 1, 1 and 2. Let's find out the determinant. This determinant should be 0. Because over here the system of equations is not delivering a unique solution. That can only happen if the determinant of the coefficient matrix is 0 by the Cramer's rule. Because if it is non-zero, that means it is giving unique solution, so the hypothesis of the question will be contradicted. So over here, how do we proceed with finding this? So you have lambda, 4 minus 1, which is 3, minus 3, then you have 2 plus lambda, minus 1, then you have 1 plus 2 lambda. This is 0. Sort this out, you get 3 lambda, minus 6, minus 3 lambda, minus 1, minus 2 lambda equals 0. So you get 3 lambda minus 3 lambda cancel each other. You have minus 7 equals 2 lambda, or lambda equals, or this is what? Minus 7 equals 2 lambda, so minus 7 by 2. That's what you have. Is this what it's going to be? Let's verify once more. You have 3 lambda minus 6 minus 3 lambda minus 1 minus 2 lambda equals 0. So you get minus 6 minus 1, which is minus 7, equals 2 lambda. So lambda is minus 7 by 2. Now over here with this particular lambda, the question is, if you incorporate this lambda over here, you are going to have this system of equations deliver you with a non-unique solution. Now, non-unique solution can be either a no solution or an infinitely many solutions. The next part of the question says, is it have no solution? That means, does it have no solution corresponding to this lambda, or does it have infinitely many solutions corresponding to this lambda? For that, we will have to jump into the concept of D1, D2, D3 followed by the Cramer's rule. Cramer's rule says if your D is 0, but at least one of D1, D2, D3 is non-zero, you have no solution. And if all D1, D2, D3 along with D are 0, that means you have infinitely many solutions. Where what is D1? D1 is nothing but the determinant of the coefficient matrix when the first column of the coefficient matrix is replaced by this particular column of 1, 2, minus 1, basically in this case. D2 is what? When the second column of coefficient matrix is replaced by these, basically the column of these 3 numbers, then you get the determinant D2. And in D3, you replace the third column by this particular column of these 3 numbers sitting on the right hand side, and that determinant is the D3 determinant. So let me repeat, if your D is 0 and at least one of D1, D2, D3 is non-zero, you get no solution. And if your D is 0 and along with D all three of them from among D1, D2, D3 are 0, that means you have infinitely many solutions. So why don't you check D1, D2, D3 with this help of lambda? Why don't you check D1, D2, D3 and see whether all 3 are 0 or there is at least one among D1, D2, D3 which is non-zero? Check it out, and then I am going to continue further and we are going to complete its solution. So could you attempt? What did you find out? Is D1, D2, D3 all 0 or there is one of them which is non-zero? Well, the claim is the moment you start finding D1, that means you find the determinant of the coefficient matrix with just first column replaced. The second and the third column are exactly the same, 3, 2, 1 and minus 1, 1 and 2. And the first column is replaced by 1, 2 and minus 1. When you do this and you find the determinant, what is it that you get? 1 into 4 minus 1, that is 3, minus 3 into 4 plus 1, that is 5, minus 1, 2 plus 2, that is 4, and you get 3 minus 15 minus 4. What is it that you get? 3 minus 4 gives you minus 1, minus 15 minus 1 gives you minus 16, which is not 0. I do not care about what is D2 and D3. I have got at least one among D1, D2, D3 which is non-zero. That means D is 0 but one among D1, D2, D3 is non-zero. So, answer is there is absolutely no solution. So, of course, there is no unique solution. In fact, there is no solution for this particular lambda which is minus 7 by 2. And so, the first part was that you do not want unique solution. That means either no solution or infinitely many solutions exist for this lambda. So, by the fact that we do not want unique solution, we found the value of lambda. And then by further understanding the Cramer's rule, we found whether for this lambda there is no solution or infinitely many solutions, and we obtained that there is absolutely no solution for this particular lambda. Of course, there is no unique solution, but in fact, there is absolutely no solution for this lambda is what we have found. Now that we have done this question, which was very easy, a direct application of the Cramer's rule. You know the Cramer's rule, you'll sail through this question like anything. Now let's see what happens to be the next question. Okay, so the 21st question is wanting you to be clear with the concepts of differentiability or continuity. Well, now this question basically is not giving you a choice to either be clear with differentiability or continuity, because for differentiability you need continuity to be clear to you, because any differentiable function is already continuous, and that is the first concept we are going to use over here to tackle this question. The question says, give me the values of a and b for which this function is differentiable at a point C. So, I am given that this function is differentiable at C for a certain a and b. If f is differentiable at x equals C, this implies f is continuous also at x equals C. As I just said, differentiability implies continuity. So, if it is continuous at C, this implies left hand limit of f at C is equal to right hand limit of f at C is equal to value of the function at C. This is what is the condition of continuity. So, if f is continuous at C, that means left hand limit is equal to the right hand limit is equal to the value of the function at C. So, the left hand limit is what? Limit x tends to C from the negative. So, when x tends to C from the negative, function is x square, and when x tends to C from the positive, the function is ax plus b, and this should be equal to f of C. F of C is C square. Now, this x square is a polynomial. So, it is a continuous function, that is why you are going to get C square over here. Just incorporate C's value in place of x. This is again a polynomial and this is again continuous. So, you get x equals C, you can put over here, you get AC plus B equals C square. So, all in all you get AC plus B equals C square. This is one relation between A, B and C that we have got. Now, it is also given that it is differentiable at x equals C. F is differentiable at x equals C means left hand derivative of f at C is equal to the right hand derivative of f at C. So, what is the left hand derivative? Limit x tends to C from the negative, fx minus f of C upon x minus C. And what is the right hand derivative? Limit x tends to C from the positive, fx minus f of C upon x minus C. So now if x is tending to c from the negative, what is my left hand derivative? What is it? It is f of x. So when x tends to c from the negative, fx is x square minus c square, f of c is c square upon x minus c. And this is what? When x tends to c from the positive, then f of x is ax plus b, and in that case f of c is ac plus b whole upon x minus c. Let's sort this out. This becomes x plus c into x minus c upon x minus c. A square minus b square is a plus b into a minus b. This is what? Limit x tends to c, ax plus b minus ac minus b. So plus b minus b, they get cancelled. Over here x minus c gets cancelled. So you get limit x tends to c, x plus c equals limit x tends to c, a common x minus c inside the braces, but that x minus c and the denominator x minus c get cancelled, so you just get a. And a is a constant, no x is there in the expression. So limit x tends to c, a constant term, is that constant term. And limit x tends to c, x plus c, which is again a polynomial, you just plug in x equal to c, you get 2c. 2c is equal to a. That means you wanted to find out the value of a and b with respect to the point c. So a has been coming out to be twice of this point c, and what is b? So plug in a as 2c, you get what you get? If you plug in a as equal to 2c, you get 2c square plus b equals c square. So b happens to be minus c square. That is what is the answer. You have your values of a and b in terms of c. Your a is 2c and your b is minus c square. These are the values of a and b which if I plug in this particular function, at this fixed point c, my function is going to come out to be differentiable. And so the only concept, as I said, was needed was of continuity and differentiability. You should know when a function is continuous at a point, and you should also know when a function is differentiable at a point. Also, as I said, you cannot afford to deal with differentiability without dealing with continuity. Until and unless your continuity concepts are clear, you cannot talk about differentiability. This was a very fairly easy question, just a direct application of the definitions of continuity and differentiability, and you were able to find out easily the values of a and b. Let's discuss the alternative question, which is talking about continuity. It is saying give me the value of a in here in the function such that the function is continuous at 0. Now in the previous question this c was unknown, it was a fixed point somewhere in the domain, but this was unknown. Over here it's known, x is equal to 0, the point at which the function is required to be continuous. So now I am just going to use my definition of continuity. When is f continuous at x equals 0? F is continuous at x equals 0 when left hand limit of f at 0 is equal to right hand limit of f at 0 is equal to value of the function at 0. This is the beautiful concept of continuity. So what is the left hand limit of f at 0? Limit x tends to 0 from the negative f of x. This is the left hand limit. So limit x tends to 0 from the negative, what is fx? If x tends to 0 from the negative, fx is 1 minus cos 4x upon x square. This means this is limit x tends to 0, this function. Now right now I cannot plug in the value of x equals 0. You cannot do that over here. You're going to get an undefined term. So somehow we need to simplify it. Over here one formula is directly evident to be used. 1 minus cos 2 theta. 1 minus cos 2 theta is 2 sine square theta. That is what I wish to use over here. So 1 minus cos 4x is 2 sine square 2x whole upon x square. Now in the numerator you have sine 2x. Below if you get 2x, you get sine 2x upon 2x, and limit x tends to 0, sine x upon x is 1. That is what I am going to use, because limit x tends to 0, sine x upon x is the quantity 1, isn't it? And that is what I am interested in using over here, because I have x tends to 0 with me. So this becomes 2 into sine 2x whole square upon 2x whole square, which gives me a 4, and therefore I multiply a 4 above, 4 below, so that I get this. And now what I have is limit x tends to 0, or I should just take out this 8 outside, sine 2x upon 2x whole square. Correct? Because limit of a function's square is square of the limit of the function. So that is what you obtain over here. Now if x is tending to 0, obviously 2x will also tend to 0. And so the format is limit of t going to 0, sine t upon t is 1. So limit of t going to 0, sine t upon t is 1. So you get 8 into 1 square, which is 8. So your left hand limit is coming out to be 8. Let's see what right hand limit is. Limit x tends to 0 from the positive and your f of x. So when x is tending to 0 from the positive, function is root x upon root over 16 plus root x minus 4. So this is limit x tends to 0, root x upon root over 16 plus root x minus 4. You know how to deal with expressions like these. You just multiply and divide by their conjugate. 16 plus root x plus 4, 16 plus root x plus 4. So here you have a minus b, a plus b. So this becomes limit x tends to 0, root x into root over 16 plus root x plus 4 whole upon what? A plus b, a minus b is a square minus b square. So this they get cancelled. After that this they get cancelled. You're left with limit x tends to 0, root over 16 plus root x plus 4. Again a continuous function, just in the denominator, just in the numerator. So plug in the value x equals 0 over here. You get root 16 plus 0, which just leaves you with root 16. And x is tending to 0 from the positive. So root 16 will give you positive 4. Positive 4 plus 4 gives you 8. And so your left hand limit and your right hand limit are equal to each other. Which is equal to the value of the function at 0 if the function is continuous at 0. That means what is the value of the function at 0? At 0 the function is small a and it is continuous at 0. So this condition is satisfied. F of 0 is a. Right hand limit and left hand limit are 8. So my a is equal to 8. That is how, by using the concept of continuity, bringing in picture the definitions of left hand limit and right hand limit, I have found out the value of this unknown a by just using trivial definition of continuity. Both the questions just demanded your concepts of definitions of differentiability and continuity and nothing else. If that is clear, these two questions are cakewalk for anybody. So note this down, understand which all logics and concepts, these two, I used in order to find my exact limits, and note this down, understand what I have done, and then we are going to move to the next question. Okay students, just take a look at the next question. What is it trying to say? Try to deal with it and then I am going to help you out in dealing with it. So as you can see, the next question is coming from the inverse trigonometry section. One of the most interesting sections of the syllabus, I personally feel that. Now over here the question is, prove that this tan inverse of this entire expression is equal to pi by 4 minus 1 by 2 cos inverse x. The important thing is this. X is lying between 0 and 1 strictly. Now if I copy the left hand side, because I have to prove that this left hand side is equal to the right hand side. So left hand side if I copy, which is tan inverse under root 1 plus x minus under root 1 minus x whole upon under root 1 plus x plus under root 1 minus x. What do you think? How should we proceed? If I have something like this, I am stuck. I don't know how to proceed after this. Somehow, we will have to use this condition to change my x sitting over here, and because over here we have to make some expression which helps us to move further. Right now we cannot move further, we are stuck. So we are going to alter our x. In such cases we do that. We alter how x looks and then move further. So now x is given to be between 0 and 1. Just recall the graph of cos function. Just recall the graph of cos function. You can see that when the angle ranges from 0 to pi by 2, cos function delivers you with values from 0 to 1, right? So I know that cos x from 0 comma pi, which is its principal domain, to minus 1, 1 is bijective, correct? In fact, if you carefully observe, from 0 comma pi by 2 to 0 to 1 also cos function is bijective. It's strictly decreasing 1, 1 and also on 2. And that is why I am just taking one section of the domain which is getting mapped in a 1, 1 on 2 manner to a one section of the codomain or the range. So I have that cos x from 0 comma pi by 2 to 0 comma 1 is also bijective, correct? And if cos x is behaving this way, no doubt cos of any angle sitting over here is behaving the same way. So if cos x from 0 comma pi by 2 to 0 comma 1 is bijective, that means for every x belonging in 0 comma 1, there is a theta inside 0 comma pi by 2 such that cos theta is that x. So every x from 0 to 1 can be written as cos theta for theta from 0 to pi by 2 is what I am trying to say. Let me repeat what I said. For every x in 0 comma 1, I can write that x as equal to cos theta for theta coming from 0 to pi by 2. That means I can replace this x coming from 0, 1 with cos theta, with theta coming from 0 to pi by 2. But over here, if I replace x by cos theta, where theta is coming from 0 to pi by 2, I will be left with 1 plus cos theta, 1 minus cos theta, 1 plus cos theta, 1 minus cos theta. Then how to proceed? Well, I have the formula 1 minus cos theta is 2 sine squared theta by 2. 1 plus cos theta is 2 cos squared theta by 2. Why to bring fractional, or why to bring these, theta by 2's in picture, when we can just work with theta? So that's why I'm not going to make cos theta over here, right? Rather than that, I'm going to make cos 2 theta over here. So that 1 plus cos 2 theta is my very neat 2 cos squared theta, no theta by 2 in picture. 1 minus cos 2 theta is 2 sine squared theta. That is what I am interested in. So if cos x is behaving in this manner, cos 2x is also behaving in the same manner. Is that correct? And that is why I am going to replace x by cos 2 theta. Because if for every x sitting in 0, 1, there is a theta in 0, pi by 2 such that cos theta is that x. Therefore, for every x sitting in 0, 1, if I consider cos 2x as my function, still there is over here a theta inside 0, pi by 2 such that cos 2 theta is that x. That is why the very argument which is true for cos x is also true for cos 2x, and that is how I have, by using the concept of cos x, delivered the exact same concept for cos 2x, and just to get a simplified expression, I am replacing x by cos 2 theta, where this 2 theta angle is coming from 0 to pi by 2. Because I want x to come from 0, 1, so this angle should come from 0 to pi by 2 only. That is how here bijectivity is concerned. So what is happening then? You get tan inverse under root 1 plus cos 2 theta minus under root 1 minus cos 2 theta whole upon under root 1 plus cos 2 theta plus under root 1 minus cos 2 theta. So this becomes what? Tan inverse 1 plus cos 2 theta is 2 cos squared theta. 2 cos squared theta inside the under root gives you root 2 cos theta. Is that correct? Because cos is positive, angle is coming from 0 to pi by 2, cos is positive, so root will be giving you a positive answer, minus under root 2 sine theta, because 1 minus cos 2 theta is 2 sine square theta, so this is going to become root 2 sine theta whole upon root 2 cos theta plus root 2 sine theta. Root 2 comes out common from numerator and denominator and it gets cancelled. You're just left with cos theta minus sine theta, cos theta plus sine theta. And here you have tan inverse. Somehow let's try to create tan inside, okay? For tan I need sine upon cos. So let's do one thing. Divide numerator and denominator by cos theta. So you will get cos theta upon cos theta, which is 1 minus sine theta upon cos theta, which is tan theta. Then you have cos theta upon cos theta, which is 1 plus sine theta upon cos theta, which is tan theta. Now I can directly write this as a certain formula, but in order to show you what that is, let me do some manipulation. I can write 1 as tan pi by 4. Tan pi by 4 minus tan theta upon 1 plus tan pi by 4 tan theta. That's what I can write this, no problem. I am just replacing 1 by tan pi by 4. But here what I have got after doing this manipulation is tan A minus tan B upon 1 plus tan A tan B, which is tan inverse tan of A minus B. And now I am very much desperate to write this to be equal to pi by 4 minus theta. I wish to cancel this tan inverse and tan and write this angle. Can I write this always? Well, no. Tan inverse of tan x is equal to x if and only if x is coming from where? Tan inverse of tan x is x if and only if x comes from minus pi by 2, which is the principal domain of tan. Now, if 2 theta is coming from 0 to pi by 2, theta is coming from 0 to pi by 4. And if theta is coming from 0 to pi by 4, minus theta is coming from minus pi by 4 to 0. So, pi by 4 minus theta is coming from 0 to pi by 4. Pi by 4 minus theta is ranging from 0 to 45 degrees. And that means what? If pi by 4 minus theta is ranging from 0 to pi by 4, this clearly means pi by 4 minus theta belongs in the principal domain of tan. And that is why there is no question over here. You can very well write it like this because the condition is being met. Now, over here I wanted to show that the left hand side is equal to pi by 4 minus half cos inverse x. What I have got is pi by 4 minus theta. Somehow this theta has to turn out to be cos inverse x divided by 2. How do we do that? Well, obviously, I know cos 2 theta is x. So, can I write this as 2 theta equals cos inverse x, which implies theta is equal to cos inverse x by 2. Can I write this? Because if I am able to write theta like this, and if I replace this as in the place of theta, I get the exact right hand side which I want. But is this every time valid? No. The concept is cos x equals y implies and is implied by x equals cos inverse y. That means from here you can write this only and only when this x, which is the input of cos, is coming from the principal domain of cos, which is 0 comma pi, and the output produced by cos, which is y, is coming from minus 1, 1. Over here the input is 2 theta, it should come from 0 to pi, it is coming from 0 to pi by 2, definitely it is coming from 0 to pi. The output, which is x, should come from minus 1 to 1, it is coming from 0 to 1, which is definitely a section of minus 1 to 1. So, even that is satisfying my condition, and therefore from here I can go here and then here, and thus you have LHS equal to pi by 4 minus theta, where theta is cos inverse x by 2, which is your right hand side. And that completes the proof because you have shown that your left hand side is equal to the required right hand side. That is how the argument takes place. In the beginning we were stuck as to how to proceed, but the very conceptual knowledge of trigonometric functions helped us to sail through the question. We recalled the cos graph, then we, in order to get more simplified expression, we replaced x by 2x and we used cos theta. After that, the solution just started becoming very smooth. Then we revised our concepts of when does the inverse trigonometric function come into picture, and once that was done, revised, we obtained our right hand side very successfully. Let's now look at the very last question of this section. Okay, so it is concerning probability again. Find the probability of drawing a diamond card in each of the 2 consecutive draws from a well shuffled pack of 52 cards which you know, if the card drawn is not replaced after the first draw. That means there is a deck of 52 cards. You are putting your hand inside the 52 cards, drawing a card. Then this card which you have drawn is not being put back inside that deck, and so now you will be left with 51 cards. You are again putting your hand in the 51 cards and you are drawing another card. You have to tell me what is the probability that first time when you draw a card it's a diamond card, and then you've kept it with yourself. That means you're left with 51 cards. The next time, just exactly consecutively after that, when you put your hand again in the deck of 52 cards and you draw the card, find the probability that again it is a diamond card. So let's do that. Let A be the event of drawing a diamond card in the first draw. Fine? Then, what is the probability of drawing a diamond card in the first draw? Well, this is very easy. You have 52 cards, out of them 13 are diamonds. So, the probability is favorable outcomes upon total outcomes, which is 1 by 4. And that happens to be the probability of drawing a diamond card in the first draw. Now, the moment you have drawn this, you are considering that the first card is drawn. Now, when the card is drawn, you are left with 51 cards. Now, you are left with 51 cards and again you wish to draw a diamond card. So, now you have favorable outcomes as 12 because we have already been done with event A. There at that time there were 13 options with us, 13 possibilities of drawing a diamond card. Now because one is already exercised, that is why you are left with 12 favorable outcomes out of the total number of outcomes, which is 51. So therefore, because of the fact of not being replaced, not replacing the card after the first draw, my favorable outcome and total outcome both are reduced by 1, and therefore if B is the event of drawing a diamond card in the second draw, then probability of drawing a diamond card in the second draw when a diamond card in the first draw has already been drawn is given by the probability of B by A, conditional probability. Probability of event B happening when event A has already happened is what? The favorable outcomes now become 12 and the total outcomes now become 51. So this becomes what? 4 by 17. The question is, give me the probability that in the first draw you draw a diamond card and in the second draw also you draw a diamond card. That means I have to find probability of event A and event B both happening together. In the first draw also I am getting a diamond card and in the second draw also I am getting a diamond card. That means the event is A intersection B. I wish to find out the probability of A intersection B. Exactly what I said, conditional probability formula tells me that this is equal to probability of A into probability of B by A. Probability of A we just found out to be 1 by 4 and probability of B by A came out to be 4 by 17. And that gives me 1 by 17. And that is what is my answer. So the probability of drawing a diamond card in the first draw, not replacing it and yet putting your hand again and drawing a diamond card in the second draw as well, the probability of both these situations occurring together is 1 by 17. Just the conditional probability concept was used. Analyze the question, understand, and this is how easily the solution flew. Now that we have completed this section C, I'm going to end my session over here. You are supposed to collect all the questions. The solutions have already been done with you, discussed with you. Practice them hard, because do not forget, the more time you invest with something, the more benefit you reap from that thing. So do not forget this lesson, and so invest quality time with these questions, practice them hard, and then you will be able to master them and score excellent marks in your exams. See you next time. Till then, take care and goodbye.